All right, hello everybody. We're going to be covering the second chemistry lesson on the classification of matter. So let's go ahead and begin. Matter is anything that has mass and takes up space. You can describe matter either with physical or chemical properties. Physical properties are properties that you can measure or observe without changing the composition of the material. That means these are things, ways of describing any object that have nothing to do with changing what's inside of the object. So here's your examples. You could either describe an object based on its density. Density is how much matter is packed into a given volume or space. So something's really dense if a lot of stuff is packed into a small space. Something is not dense if it takes up a lot of space, but there's not much matter in there. So for example, is a rock dense? Yes, it is. It's small, but it's heavy. There's a lot of stuff packed in there. Is an empty water bottle dense? No. It takes up plenty of space, but there's not much matter in there. So that's example of density. Malleability. Something is malleable if you can hammer it into a thin sheet, meaning you hit it with a hammer, instead of just busting into a billion pieces, it flattens. That's what malleability means. Ductility describes if an object can be drawn into long, thin wires. You'll notice D-U-C-T. I don't know if you're aware of this, but duct tape is not spelled duck like the bird. It's not D-U-C-K. Duct tape is D-U-C-T tape because it's ductile, meaning that tape is made up of a bunch of little thin wires. That's why duct tape is so strong, because it's a whole bunch of little sticky thin wires stuck together rather than just one big sheet. So ductility describes if an object can be drawn into thin wires. And lastly, conductivity is the ability of a material to transfer heat or electricity between its particles. So that's a physical property. A chemical property describes how a matter is going to change. So how any piece of matter will change, whether that's because it's around other materials or because you add energy to it. Here's an example of a chemical property. When you take gasoline and you mix it with oxygen and heat it up, it's going to react with the oxygen in the air and it's going to combust, meaning it will bond with the oxygen and make an explosion. So gasoline, what's a chemical property of gasoline? It's combustible with oxygen if you add heat. Okay, that's an example of a chemical property. I could describe gasoline of calling it dense or malleable or ductile. That has nothing to do with how it interacts with other things. The moment I'm talking about how it's going to change in the presence of other stuff, that's a chemical property. And then with that, you can describe something based on a physical or a chemical change. A physical change is a change an object undergoes that doesn't change its identity. So something just bending. Even if you boil, water could be in the pot and you give it heat and it turns into a gas. It's still water. It didn't bond with anything new. So physical change is a change that doesn't change the matter. Chemical change, let me go back. A chemical change is a change that results in you change the composition and you have a different chemical makeup after you undergo that change. So here's an example. Plain iron, the element Fe is what iron is. Plain iron. Well, if that is interacting with the oxygen in the air, they bond and become iron oxide, and that's what rust is. So I'm not talking about iron just folding or bending. I'm talking about it actually combining with oxygen and becoming it has a new chemical formula. It's a whole new type of matter. All right, so before we move on to this, I want you guys to look at your questions, and numbers 1, 2, and 3 cover chemical, physical properties or changes. Go ahead and I want you to pause this, answer those 3 questions, give it your best, and then press play and I'll go over it. All right, so hopefully by now you've done that. So which of the following physical properties describes how easy a material can be hammered into thin sheets? Well, that would be malleability. Malleability is hammering it into thin sheets. Which property explains why a pillowcase filled with rocks is heavier than a pillowcase filled with feathers? They both are a pillowcase. They both take up the same amount of space. Why is one heavier than the other? Well, that's because rocks are dense. They have a lot of matter packed in their small space, whereas feathers fill up space but have hardly any matter packed in them. So density would be your answer there. Okay, pick an object around you and describe it using all four physical properties. I will do that with this water bottle I have right here. It's pretty much an empty water bottle. Is it dense? No. Tons of empty space. So it takes up a lot of space, but there's not much matter in it. Is it malleable? Yes. If I was to smash it with a hammer, it wouldn't blow up into a billion pieces. It would crunch down and be very flat. Is it ductile? No, I don't think it is. If I were to cut this with some scissors or something, it would not be flaking into little thin wires. It would just be big chunks that are together. And then lastly, is it conductive? Definitely not. This thing is not going to transfer electricity, and I could hold one end and stick the other end in a fire, and the other end is just going to melt. The end I'm holding is not going to start getting hot. All right. Imagine if I took like a metal pole. If I stick one end in the fire, the end I'm holding is going to start getting hot and burn me. Not the case with this water bottle. So I want you to pick any object in the room. Make sure you describe it using those properties. Start applying them to something around you. All right, let's go to the next concept here. So you can either have a pure substance or a mixture. A pure substance consists of one type of matter. So it's either an element or a compound. If you have just pure gold, pure lead, just plain water, glucose. If you have just one type of substance, it's then going to be a pure substance. A mixture is when you have multiple pure substances and you mix them together. Now, I want to note, a mixture is not talking about rearranging the chemicals and making new bonds. You're not going to break old bonds and make new bonds. What you're going to do is you're just going to mix some pure substances together, meaning they can get separated by a chemical or by a physical change still. So you don't have to break bonds to separate them. Now, once you have a mixture, you can either have a heterogeneous or a homogeneous, sometimes pronounced homogeneous, mixture. Now, hetero means different, and homo means same. So a heterogeneous mixture, you have multiple types of pure substances, and you can see the difference in them, like oil floating on top of vinegar. You can very, very clearly see that there's oil, and then there's another phase of vinegar. Whereas a homogeneous mixture or homogeneous mixture, all you see is one single phase. So that would be like if you make some chocolate milk. Take your milk, throw the chocolate in there. It's heterogeneous if you see the chocolate floating on top. But the moment you stir it and it all looks the same, it's now homogeneous. All right, so actually, with that, I want you to go ahead and answer numbers 4 and 5. So press pause, answer these, press play when you're done. Okay, so tap water. First off, is there just one type of substance in there? No, there's not, so it can't be pure. There's all sorts of weird stuff floating in tap water. This question, I guess, is kind of open-ended, but because sometimes there might be stuff in your tap water you can see floating around, which would make it heterogeneous. But in general, most of the time you find tap water, you know that there's different, calcium and fluoride and different stuff floating in there. You just can't see it. It looks like normal water. So the answer to this one would be homogeneous because it all looks the same. Purified water, meaning absolutely nothing is inside that water. Well, that would be a pure substance. It's just plain water with nothing in it. All right, let's go back to the slides. So when we get into discussing atoms and elements and all this, here's what those terms mean. An element is a pure substance that can't be broken down any further. For example, if I take my water, break it down, it's H2O. I'm going to break it down into 2 hydrogens and an oxygen. Well, hydrogen is an element. Oxygen is an element. So once you break down a pure substance and it can't be broken down any further, you have yourself an element. And then an atom is a basic particle of an element. So I could have a hydrogen atom, an oxygen atom. Now, inside of the atom, there are positive particles called protons. Remember positive because it starts with a P. Neutral particles are neutrons. So you can hear the word neutral in there. And then lastly, negative particles are called electrons. So here's how it works. If you're inside of an atom, you have the same number of electrons and protons. Remember, negative and positive. If you have the same number of each of those, they balance each other out, and you have a neutral atom. When you have more protons, because protons are positive, if you have more protons, you now have a positive atom. If you have more electrons, it's a negative atom. In any case where you have more protons or electrons, you have a charged atom. We will call those ions. So ions are charged atoms. Now, there's two different types of ions. If you're a cat lover, then this will work out for you. If you're a cat lover, then you can remember that cats are a positive thing. So cat ions are the positively charged ions. And then the way I remember this is ants. I don't like ants. When ants are in your house, it's bad news. They're going to eat all your food. They're not, I don't like having them all over my stuff. So ants are a negative thing. So anions are negatively charged ions. And then anytime you group a bunch of atoms together, they make a molecule. So molecules are groups of atoms. All right, let's look at this question right here. Go ahead and give number 6 a try. Press pause, try number 6, and then you can go ahead and play it. All right, number 6. The atom has more electrons than protons. Which one is negative? Which one is positive? Electrons are negative. Protons are positive. So in this case, we have more negatives. So that means it's going to be, if there's more negatives, it's going to be an anion, because those are the negative things. And it's going to have a what kind of charge? A negative charge. So anion and negative. Here's your answer right here. All right, so let's move on to the last slide. So a chemical symbol, whenever you have a group of elements, you need to be able to name them. So we have special symbols. Now, the first letter will be capitalized, and if the symbol of an element has more than one letter, the second letter will always be lowercase. Let me show you why that's important. Plain old C is carbon. Makes sense. Plain O is oxygen. That makes sense as well. So then CO, since C was taken by carbon, if you have cobalt, we name that CO. That also makes sense. But look at what we have to do. You have to have the second letter lowercase if you are talking about cobalt. The reason being is because if you have CO, this right here is not cobalt. Since it's capitalized, I'm talking about carbon. And then since this is capitalized, I'm talking about oxygen. So this would be carbon and oxygen mixed together, which makes carbon monoxide. So this right here would be cobalt. This right here would be a carbon and an oxygen. That's an important difference. And so what happens, a compound is a pure substance that consists of two or more elements are chemically combined. Because it's not just a random mixture, a compound has a specific formula to make up each compound. So what happens is you can have a chemical subscript. That's the small number that tells you you have multiple elements. And a coefficient is a large number in front of the whole compound. So let me show what I mean. It would be something like this. How many atoms are in each of the compounds? So look at this, C2O3. This little number tells me just how many of the C's. This is just how many of the O's. So C2O3 would be 2 carbons and 3 oxygens. C4H10, 4 carbons, 10 hydrogens. What about C2H4O2? 2 carbons, 4 of the hydrogens, 2 of the oxygens. Now, let's make this thing a little bit more complex. What happens if we take this and we have the same thing all over again, but there's a 3 in front of it? Okay, now that is up here, the coefficient, the large number in front of it. If you have 3 C4H10, this means that whatever amount I had right here, I'm tripling it. I have 3 of these. So if I would have had 4 carbons, but I have 3 of them, you do, what's 3 times 4? Your answer now would be 12 carbons. I was going to have 10 hydrogens, but I tripled it. What is 3 times 10? The answer is going to be 30. All right, so go ahead and try 7, 8, and 9. Give that a try. do your best on it, and then when you're done, so press pause, try that, and when you're done, press play, and I'll go over the answers. All right, number 7. How many sodium Na atoms are present? How many of Na do you see there? Well, there's only 2 of them, so your answer would be 2. Okay, right here, how many oxygen atoms are present? Look at how they do this. There's 1 magnesium, 1 Mg. Notice how NO3 is grouped here with a 2. That means double everything that's in here. So how many N's do I have? It would have been 1, but there's a 2, so I double that. So there's 2 N's. How many O's do I have? There would have been 3, but I double it. What's 3 times 2? 6. So there should be 6 oxygens. Okay, last one. In the given formula, how many calcium atoms do you have? Calcium right here, there would have been 1, but there's a 3 in front, so you triple everything here. So calciums, there would have been 1, we now have 3. Bromines, there would have been 2, we now have 6. So you triple whatever's in here. So 3 is your answer for that. All right, guys, so that's it for lesson 2. Hopefully that makes sense to you. If you have any questions, feel free to email me. If you need help with this, go ahead and go to the tutoring session at 2 o'clock. Just send me an email when I post the announcement, and I'll give you an invite to that. So, all right, guys, have a good rest of your day, and I will see you soon.